Every second, the universe grows darker, and no one can stop it. Look up tonight, and you might think the cosmos is eternal. A frozen ocean of glittering stars, suspended in endless black. But what you see is not what is. The light that reaches your eyes has traveled for millions, sometimes billions of years. It is old light, ancient, exhausted, stretched by the breath of expansion. And slowly, relentlessly, it is fading. There was a time when the universe blazed. Galaxies shone like lanterns across the void. Stars burned with furious intensity, colliding, collapsing, igniting the night in waves of newborn light. The cosmos was a place of fire. But age is cruel, even to the infinite, and what we are witnessing now is the long twilight of creation, the gradual dimming of everything that ever shone. Where is all that light going? It doesn't vanish. Photons, those tiny, immortal messengers, never truly die. Once born in the heart of a star, they journey outward forever, unbroken, unstoppable. Yet something strange happens as they move through the expanding universe. Space itself stretches beneath them. The distance between every galaxy grows, and with it, the wavelength of every photon. Blue light becomes red. Red becomes infrared. Infrared becomes invisible. The same energy that once painted the universe in color is being drawn out, like ink diluted into water. The glow is not gone. It's merely slipping beyond what we can see. This is the redshift, the great fading of the cosmos. Every passing second, the light of distant galaxies grows fainter, their once proud signatures dissolving into longer and longer waves. The expansion doesn't just pull matter apart, it stretches memory itself. The universe is taking its own story and rewriting it in silence. Imagine an orchestra playing a symphony that never ends. Each note rings out, but as the hall expands, the sound softens, slows, drifts away into a deepening quiet. That is the fate of starlight. Every photon still travels, but the space it travels through betrays it. The melody of the cosmos continues, yet we hear less and less of its song. In our time, this brief, brilliant instant in cosmic history, we live within a privileged glow. The stars still shine, galaxies still shimmer, and our instruments still catch their whisper. But already, the night is changing. Many galaxies visible to early astronomers have vanished from our reach. Their light still moves toward us, but the universe has expanded so much that their signal stretches into radio waves too long for our eyes or telescopes to perceive. The edge of visibility recedes, like the tide pulling away from the shore. And one day, even the nearest galaxies will slip beyond the horizon of light. The Milky Way and its companions will become an isolated island, surrounded not by constellations, but by blackness. Future civilizations, if any remain, will gaze up at a sky empty of everything we now know. They will not see Andromeda, nor the Virgo cluster, nor the faint mist of the cosmic web. They will see only the cold stars of their own galaxy, unaware that beyond that dark, unreachable veil, trillions of suns still burn. The light of the universe is not dying in the way a flame dies. It is not extinguished, only diluted. Every photon stretches, cools, and fades, its energy smeared thin across the growing canvas of space-time. In the deep future, long after the last star has burned out, this ancient radiation will still ripple through the void, ghostly, endless, invisible. The night will not end with a bang, but with a slow sigh into darkness. And yet, there is poetry in this loss. The light that leaves a dying star may wander for billions of years before brushing across a human retina or a telescope mirror. It may be older than life itself, a survivor of collisions, of cosmic storms, of eons of expansion. When you look up at the night sky, you are seeing the last remnants of that ancient fire. You are witnessing memory. Light stretched to its limits, struggling to reach you before the darkness closes in. We are children of that fading glow, living in the afterglow of creation. Our atoms were forged in the very stars, whose light now slips away. To look into the night is to look backward in time, to see not what is, but what was, slipping through the cracks of the universe's own memory. Every second, the light continues to stretch. Every heartbeat, another photon slips past the threshold of visibility. The cosmos is not ending. It is dimming, like a theater after the final act, as the audience sits in awe, reluctant to leave. The question remains, when the last light finally fades, what will be left to see? Or perhaps, more hauntingly, who will be left to remember that it was ever bright? The light that touches your skin tonight began its journey before humans existed. It was born in silence, not in the empty silence of space, but in the dense, crushing heart of a star. A place where matter itself trembles, where atoms are squeezed so tightly together that the boundaries between them blur. Here, under unimaginable pressure, hydrogen, the simplest element in the universe, fuses into helium. And in that instant, when two atoms become one, a miracle happens. A spark of light is born. That spark is a photon, the smallest, purest fragment of illumination the cosmos can make. It has no mass, no rest, no shape that can be held. It is energy made visible, a ripple in the electromagnetic field, a single trembling note in the grand symphony of existence. But its birth is no gentle event. Inside the core of a star, where temperatures soar to 15 million degrees, a photon emerges into chaos. It is created in an instant and immediately trapped. The very plasma that gave it life becomes its prison. A photon cannot escape easily. The stellar interior is so dense that light travels only millimeters before colliding with another particle, scattering again and again like a prisoner bouncing off invisible walls. For a photon born in the sun, the journey from the core to the surface may take tens of thousands, even millions of years. Each collision changes its direction, steals a fraction of its energy, and shifts its color. What begins as a violent burst of gamma radiation slowly softens into visible light by the time it reaches the star's surface. Every photon that eventually reaches open space has lived through a lifetime of chaos. A billion ricochets, 1,000 transformations, an eternity compressed into its brief existence inside that stellar womb. When it finally escapes the surface, it is flung into freedom at the speed of light. 300,000 kilometers per second, the ultimate cosmic limit. Now nothing can catch it, not gravity, not time. It will never stop, never age, never slow down. From this moment onward, its journey belongs to the infinite. And so it travels, through the void, through the long corridors between stars, where silence is so complete that it becomes a kind of music. The photon carries with it the memory of its birthplace, the nuclear fires of a star that may already be dead. Does not know death, but it knows change. Every dust grain it meets, every atom it grazes, may bend or scatter it, shifting its color or direction. It may be absorbed, only to be reborn again from another atom's embrace. Light is never destroyed. It only changes form, echoing the universe's deepest law. Energy is eternal. Our photon sails through interstellar space, a place that looks empty but is not. It passes through veils of hydrogen gas, through the faint wisps of nebulae glowing like ghostly curtains. Dust grains drift in its path, and when it strikes them, it scatters into a spectrum, red, orange, blue, painting the universe in the subtle colors we see through telescopes. Every cloud of gas, every reflection nebula, is just sunlight, or starlight, broken and refracted, tears of light scattered across time. And then there is darkness again, vast, immeasurable. For thousands of years, our photon travels untouched. Galaxies drift apart, civilizations rise and fall, planets form and die, and still it moves forward, unstopping, unthinking. To us, this would seem endless. To the photon, no time passes at all. From its own frame of reference, the moment of its creation and the moment of its arrival are the same. To a photon, the universe has no duration. The entire history of existence, billions of years, collapses into a single, eternal now. In that way, light is both the oldest traveler and the youngest. It experiences no waiting, no aging, no becoming. It simply is. It carries information. The fingerprint of atoms, the signature of stars, the record of all that was ever illuminated. Light is the universe remembering itself. Eventually, after crossing unimaginable distances, our photon may encounter something, a planet, an atmosphere, an eye. Perhaps it travels from a distant galaxy, emitted when dinosaurs still roamed Earth, and finally meets its end against a telescope mirror in a quiet desert. In that moment, after billions of years, it ceases to travel, its journey complete. It transfers its energy to an electron, which leaps into motion, triggering a spark of electricity, a signal, an image. A scientist sees a faint smudge of light on a screen. And in that instant, an ancient story is told. Every image we've ever taken of the universe, every galaxy, every nebula, every supernova, is made from such stories. Each photon a witness, a messenger from the past. The light of the Andromeda galaxy left its home 2.5 million years ago, long before humanity painted on cave walls. The light of distant quasars began its voyage before the Earth even existed. When we study them, we are not seeing where they are. We are seeing where they were. The sky is not a view, it is a memory. And yet, not every photon finds an audience. For every one that reaches a human eye, countless others vanish into the cold. Some are swallowed by black holes, their paths curving toward singularities from which no light escapes. Others drift endlessly, their wavelengths stretched by the expanding fabric of the cosmos until they fade into the background. The cosmic microwave echo, the afterglow of the Big Bang itself. That ancient radiation, still humming faintly around us, is the collective whisper of every photon ever released at the dawn of time. Our photon, if lucky, may escape such a fate. But even it cannot outrun expansion. As it travels, the very space between its peaks and troughs stretches, lengthening its wavelength, softening its color. What began as brilliant white becomes dull red, then fades beyond visible light. The further it goes, the more the universe takes from it. Not by touch, but by distance. It is light, unraveling into invisibility. There's tragedy in that, but also grace. For in losing energy, light paints the cosmic story across every scale. It cools galaxies, warms planets, sculpts shadows, feeds life. It becomes the soft dawn on alien worlds, the warmth on a creature's skin, the reflection in a child's eye. That photon, once born in violence, now becomes tenderness. Its purpose fulfilled not in power, but in connection. But what, really, is a photon? Physics describes it as a quantum, a discrete packet of electromagnetic energy. It has no rest mass, no charge, no internal structure. It is a pure excitation of the field that fills all of space. And yet it behaves both as a wave and as a particle. It interferes with itself, diffracts through slits, carries momentum, and exerts pressure. It is not just light. It is the very definition of movement without matter. Einstein called it the light quantum. Through it, he revealed that light has dual natures, both continuous and discrete, both wave and particle. But deeper still lies a philosophical truth. Light resists boundaries. It refuses to be one thing. It is certainty and uncertainty intertwined. Perhaps that is why we are drawn to it, because it mirrors consciousness itself, both defined and infinite, both local and boundless. Our photon's journey mirrors our own search for meaning. It was born from fire, struggled through density, escaped into freedom, and traveled across darkness, carrying the memory of its origin. And when it is finally absorbed, it does not die. It transforms. That transformation, of light into life, of energy into awareness, is the same rhythm that drives everything in the universe. Consider this. The sunlight warming your skin today began as nuclear fire tens of thousands of years ago. It battled through the chaotic depths of the sun before it ever saw space. By the time it reached you, it had become soft, visible, alive. And when it strikes your skin, it triggers chemical reactions that sustain life itself, allowing plants to grow, oceans to move, eyes to see. In that sense, every living thing is powered by ancient photons, fragments of stars made flesh. When you close your eyes at night, that energy still flows through you. You are a continuation of that light, a temporary structure built by its power. The cosmos is not just illuminated by light. It is light slowed into form. Matter itself is frozen energy, waiting to move again. The distinction between solid and radiant, between being and shining, is only a matter of speed. Our photon moves on, passing through distant regions of intergalactic space, where galaxies appear as faint smears of light. It may brush past the halo of a massive cluster, its path bent by gravity, the invisible curvature of space-time turning light itself into a storyteller. These gravitational lenses reveal the unseen mass of the universe. Without the bending of photons, we would never have known the presence of dark matter, the ghostly scaffolding that shapes everything. Light, by losing its straight path, gives shape to the invisible. But even light has a limit. In the far future, as the universe continues to expand, the last photons will fade. Their wavelengths will stretch beyond detection, their energy diluted to near nothing. The universe will cool into darkness, a silent sea where light still exists, but in a form so weak that it can no longer touch matter. And yet, even then, those photons will travel through infinity, through nothingness, through time beyond time. The story of the universe will continue, written not in brightness, but in persistence. For light, like memory, never truly ends. It only fades into forms beyond perception. It becomes the echo of what was, the ghost of creation still wandering through the night. Our photon, now stretched beyond all recognition, drifts through the cold. It has seen the rise and fall of stars, the birth of galaxies, the death of worlds. It has passed through the eyes of creatures who wondered where it came from. And perhaps, in that wondering, the photon finally fulfills its destiny, to make the universe aware of itself. For what is light, if not the act of the cosmos seeing its own reflection? It began as fire, became memory, and now dissolves into silence. Somewhere in the darkness, another photon is born. Another story begins, and the great endless dialogue between energy and time continues. One pulse of light at a time. Every moment, billions of galaxies slip out of sight forever. The universe is expanding. Not into anything, not pushing into some waiting void, but expanding itself. The fabric of space stretches, and with it, everything within. The galaxies are not moving through space as much as space itself is moving through them, carrying each one farther from the others, like ink bleeding across an endless sheet. And with every heartbeat of cosmic time, that stretching leaves its signature. Light itself is being undone. The photons that once blazed across the young universe now travel on a road that lengthens beneath them. As they move, their waves stretch, their frequencies drop, and their colors shift. What was once brilliant blue becomes red, then infrared, then microwave, until finally the light fades into invisibility. This is redshift, the slow draining of energy from light, not through collision or loss, but through time itself. 100 years ago, when Edwin Hubble pointed his telescope at distant nebulae, he saw something the world was not ready to believe. The spectral lines, the fingerprints of atoms, were displaced toward the red end of the spectrum. The farther a galaxy was, the greater its redshift. Hubble realized that space wasn't static at all. The universe was swelling, like the surface of an inflating balloon carrying the galaxies apart. Every wavelength of light, the universe's own chronicle, was being rewritten. It was the first proof that the cosmos had a beginning. For if everything was once closer, there must have been a time when everything was one. A single point of searing density and light. The Big Bang wasn't an explosion in space, it was space expanding. And ever since that moment, light has been on the losing side of the equation. To understand redshift is to understand loss. Imagine a single wave of light, a crest and a trough, a rhythm of energy moving through space-time. Now imagine stretching the space between crest and trough farther and farther apart. The light's color reddens, its energy drains. The photon still travels at the same speed, the cosmic speed limit, but the energy it carries weakens with distance. The universe robs it gently, endlessly. Every second, the cosmos cools by stretching its own light thinner. This process is not the same as the Doppler shift you hear when an ambulance passes. It's siren, changing pitch. That shift happens because of motion through space. The cosmological redshift, on the other hand, arises because space itself expands. There is no edge, no center, no external stage. Everything stretches uniformly, and every photon, no matter where it travels, is a casualty of that expansion. The evidence lies everywhere. Galaxies beyond our local group are receding. The farther we look, the faster they go. This relationship, Hubble's law, defines the rhythm of the cosmos. Velocity, Brachedhan ct countries, x distance, each megaparsec away, corresponds to a recession velocity of roughly 70 kilometers per second. At a billion light-years, that means galaxies are flying apart at tens of thousands of kilometers per second. And beyond a certain distance, they move away faster than light itself. Not because they break any rule, but because the space between us expands faster than photons can cross it. Those galaxies are gone forever. Their light will never reach us. Every moment, new galaxies slip across that boundary. The cosmic horizon. The universe doesn't consume them violently. It erases them gently, like colors bleeding out of a photograph left too long in the sun. Their light still exists, traveling endlessly, but it will never arrive. It is stretched into silence. Astronomers call this the observable universe, a sphere about 93 billion light-years across. But that term hides something haunting. It is shrinking in meaning. The observable universe defines not what exists, but what remains visible to us. Beyond its boundary, the rest of reality continues, unseeable, unreachable, intact. We are left inside a fading bubble of light, surrounded by an ocean of invisibility. The deeper we look, the older the light we see. Photons from the most distant galaxies began their journey over 13 billion years ago, when the universe was young. Their wavelengths have stretched by factors of hundreds or even thousands. What began as ultraviolet fire has become the faint red whisper our telescopes now catch. When we look at the Hubble ultra-deep field, we are not seeing galaxies as they are, but as they were. Long before our sun was born, their colors drained, their forms distorted by the slow tearing of space-time. And beyond even those faint smudges lies a light older still. The cosmic microwave background, the afterglow of creation itself. Once, it was a blinding white inferno, the light of the first free photons when the universe cooled enough for atoms to form. Now it is a dim microwave hum, spread so thin that only the most sensitive instruments can detect it. That background is not static. It too is red-shifting, cooling with every passing eon. One day, even that relic glow will fade beyond detectability, vanishing into wavelengths larger than the universe itself can measure. This is the great dissipation, the slow death of visibility. Every star that shines contributes to the brightness of the cosmos, but the darkness grows faster. The fabric of space stretches more each second, driven by something mysterious. Dark energy. Discovered in the late 1990s, it revealed a truth stranger than any before. The expansion isn't slowing down, it's accelerating. The universe is not just growing, it's racing away from itself. No one knows what dark energy is. It behaves like an intrinsic pressure of space, a repulsive force that overwhelms gravity on cosmic scales. Every cubic meter of vacuum carries a tiny, constant energy, and as the universe expands, there's more vacuum to fill. The more space there is, the more dark energy there becomes. A feedback loop that guarantees acceleration. Galaxies that are now visible will soon slip away forever. Each second marks the loss of countless suns. The numbers are merciless. Within tens of billions of years, only the closest clusters will remain visible. Beyond that, even they will fade. Future astronomers, if any consciousness survives, will see a night sky with fewer and fewer galaxies until only one remains, the merged remnant of the Milky Way and Andromeda. The rest of the cosmos will have receded into silence. For them, the universe will appear static, eternal, unchanging, the cruel illusion of isolation. That epoch is called the end of cosmology. When the last external galaxies fade, all evidence of expansion will vanish. The cosmic background radiation will be undetectable. The night sky will no longer carry the signature of its origin. Civilizations, then, no matter how advanced, will have no way to know there was ever a Big Bang. The story of creation will be erased not by ignorance, but by physics. There is a sadness in that inevitability. The universe, once radiant with memory, is losing its ability to remember. Each photon that escapes into the stretching void becomes a little dimmer, a little colder, until it can no longer tell its story. The cosmos is not dying violently. It is drifting into forgetfulness. And yet, in this fading lies a paradoxical beauty. Redshift is not destruction, it is transformation. The same stretching that dims light also reveals the structure of time itself. By studying that fading, we have learned more about our origins than any other phenomenon could teach us. The loss of light is also the gain of understanding. Every receding galaxy, every spectral shift, every faint photon captured in the deep sky tells us not only how far away something is, but how long ago it existed. The universe writes its autobiography in disappearing ink. Still, the emotional weight of it is inescapable. Every telescope image is already a memorial. We are witnessing not the living cosmos, but its ghosts. The dying embers of galaxies that may no longer exist. When we see the light from a quasar 12 billion light-years away, we are seeing the echo of something that burned out before Earth had oceans. The cosmos we observe is not the universe as it is. It's the universe as it was, long ago, stretched thin by time and loss. There is an eerie symmetry to it. Light was the first storyteller. It carried the tale of matter's dance, of stars' birth and death, of galaxies colliding and merging. It gave the universe its visibility, its meaning. And now, through redshift, that very storyteller is being erased by the story it told. Expansion itself. The act of creation becomes the act of erasure. The more the universe grows, the less of it we can see. Think of light as fabric. Each photon is a thread woven through space-time, connecting past to present. As the cosmos expands, that fabric is pulled tighter, stretched until the weave thins, and eventually the threads disappear. The tapestry remains, but its image fades. The pattern becomes invisible, though it is still there. For light, to exist is to be stretched. To stretch is to lose. And yet, without that loss, there would be no distance, no time, no motion. Redshift is not merely an effect. It is the universe's heartbeat. The pulse of expansion defines everything, from the cosmic microwave background to the faint afterglow of galaxies yet unborn. The human heart is drawn to color, to the vibrancy of what is visible. But in the grand scale, color itself is fleeting. The visible spectrum is a narrow sliver in an infinite range. As the universe expands, that sliver slides down the ladder of energy, moving beyond what eyes can perceive. The cosmos is draining of color, the blues of young stars fading to crimson, the crimson fading to black. Eventually, even black will no longer describe it, for there will be nothing left to contrast. The ultimate state of light is transparency, not brightness, not darkness, but absence. And yet, perhaps there is hope hidden in the laws that dim us. The expansion that steals our light also ensures that the universe will never collapse back into itself. The same redshift that erases galaxies keeps time moving forward, preventing eternal recurrence. The fading glow is both elegy and salvation, the price of existence continuing. In the far future, when the cosmos grows cold and quiet, light will still be there, too stretched to warm or reveal, but present as a whisper, a faint ripple in the quantum field. The great dissipation will never reach absolute zero. Entropy may win, but even in victory, it leaves behind the trace of its opponent. The photon never stops traveling. It simply forgets how to shine. So where does all the light go? It doesn't vanish into nothing. It becomes everything's background. The invisible hum of existence. The red-shifted glow of galaxies. The microwave echo of the Big Bang. The faint warmth of space itself. These are the remnants of light's long surrender. Every moment, billions of galaxies slip out of sight forever, but their light still exists somewhere, faint and stretched beyond our senses. Perhaps, in some distant corner of eternity, that invisible radiation will someday be recognized again, not by eyes, but by awareness itself. For now, we live in the luminous middle, a brief window where the universe is still visible, where photons still carry color, where starlight still speaks. We are witnesses to a cosmic twilight, a fading that will one day be complete. And as the glow drains away, leaving the universe pale and silent, one truth remains. The darkness is not the absence of light, but its destiny. The last star will shine, and no one will be left to see it. The story of the universe began with fire. Hydrogen ignited into stars, stars forged the elements, and galaxies blazed like living cities. But all fire consumes its fuel. Every act of creation is also an act of exhaustion. The cosmos has been burning for nearly 14 billion years, and already the embers are dimming. What lies ahead is not an apocalypse in flame, but a slow unraveling, a long surrender to silence. The universe, like any living thing, has stages of life. The age of light, the one we inhabit, is only the middle chapter, a brief epoch between two eternities of darkness. In the far future, stars will die, galaxies will fade, and even the most stubborn forms of matter will dissolve. The cosmos that once sang with radiation will become a graveyard of faint glimmers and frozen echoes. The process begins quietly. Even now, the engines of light are aging. The most massive stars, those that live fast and die young, have already burned through their lives in cosmic seconds. They end in supernovae, scattering heavy elements into space, seeding future worlds, but leaving behind corpses, neutron stars, and black holes, the smaller, steadier suns, the kind that give birth to planets and sustain life, are still burning, but even they are not eternal. Our own sun, 5 billion years from now, will exhaust the hydrogen in its core. Without the pressure of fusion to hold it up, gravity will crush the center inward, while the outer layers expand outward. The sun will swell into a red giant, its radius extending beyond Earth's orbit. For a brief time, it will burn with renewed brilliance, a final flare before collapse. Then it will shed its outer skin into a planetary nebula, leaving behind a dense, white-hot remnant, a white dwarf. This will be the fate of most stars in the universe. White dwarfs, dense spheres of carbon and oxygen, no larger than Earth but with the mass of a sun, will become the last beacons of the night. They no longer fuse atoms, they only glow with the residual heat of their former lives. Over trillions of years, they will cool, dim, and fade, their light bleeding away into the endless cold. Eventually, they will become black dwarfs, stars that shine no more. When the last star dies, the age of light will end. Astronomers called the next stage the degenerate era, the long twilight of the universe. In this epoch, galaxies will no longer sparkle. They will be filled with the remnants of creation: white dwarfs, brown dwarfs, neutron stars, and black holes. The great spirals we see today will dissolve into loose constellations of invisible matter, their arms unraveling as gravity grows weaker across expanding space. Galactic collisions will become rare. Star formation will cease entirely as interstellar gas is consumed or lost. The universe's vast workshops of creation, the nurseries where new suns once kindled, will fall silent. The cosmos will still exist, but it will have forgotten how to shine. Yet even this darkness is not final. The story continues, quietly, through decay and transformation. White dwarfs may occasionally collide, reigniting in brief flashes of supernova light, sudden sparks against an otherwise black horizon. But these events will become exceedingly rare. The intervals between them will stretch from millions to billions of years. Light will flicker, then vanish again. Neutron stars, too, the ultra-dense remnants of massive supernovae, will persist for trillions of years. Their magnetic fields will weaken, their spin will slow, and their pulsing radio beacons will fall silent. The universe will lose its last heartbeat. Black holes will remain, scattered across the dark. For a time they will dominate the cosmos. Every galaxy, long faded, will leave behind one at its center, a supermassive black hole, a relic of all that once was. These titans will consume whatever remains within reach. Orphaned stars, drifting gas, even smaller black holes. Galaxies will become shadows orbiting invisible kings, but even black holes cannot last forever. According to Stephen Hawking's theory, they slowly evaporate through a process called Hawking radiation, a faint quantum leakage of energy from the event horizon. For the largest black holes, this takes unimaginable spans of time, far longer than the current age of the universe, but eventually even they will dissolve into nothing, releasing their final heat in a whisper of radiation. This era hundreds of trillions of years hence, marks the universe's true descent into silence. Astronomers call it the black hole era. It will last until the very last singularity fades, leaving only faint photons and ghostly particles drifting through the dark. Beyond that, in the unimaginable future comes the dark era, the end of structure itself. By then, the universe will be so expanded that no two objects will ever meet again. Space will be vast and empty, scattered with cold remnants, degenerate particles, frozen planets, stray atoms. There will be no stars, no galaxies, no heat, no light. The temperature everywhere will approach absolute zero. In this distant epoch, time itself will lose meaning. Change requires energy, and energy will be gone. The universe will exist in perfect stillness, a state physicists call heat death. When entropy reaches its maximum and all gradients of energy are exhausted, nothing will move because nothing can. The cosmos will be full but empty, full of matter, empty of purpose. And yet, it will not have ended. There will be no cataclysm, no final explosion or collapse, just a slow fading into equilibrium. Creation will have consumed itself completely, leaving only silence. A silence so absolute it defies imagination. It's almost impossible for the human mind to grasp the scale of this decay. 1 trillion years is already beyond comprehension. Yet the timeline of the universe's death stretches far beyond even that. The stars we see tonight are temporary ornaments in an eternal night. The cosmos is still young, less than 1% into its lifespan before heat death. To imagine it is to feel something both terrible and sublime. Every atom, every photon, every star, all part of a grand story whose final act is darkness. The same forces that built everything we know will one day undo it, not with violence, but with indifference. The fire of creation was never meant to last. But perhaps there is a strange grace in this ending. The last star to shine will not go quietly. It will be a red dwarf, the smallest and longest living kind of star, burning its hydrogen slowly and efficiently. These tiny suns, too dim to be seen with the naked eye, may live for trillions of years. Their twilight will outlast the universe's current age 1,000 times over. When the final red dwarf begins to fade, it will do so alone. The cosmos will be vast and nearly empty by then, the galaxies scattered so far apart that no other starlight will reach it. Its glow will fall across nothing but dust and cold rock. For one brief moment, it will stand as the last lighthouse in an ocean without shore, and then, one day, its flame will go out. Its light will travel outward forever, but there will be no one left to see it. No eyes, no planets, no minds, only expanding space to swallow the final spark. The universe will exhale its last breath of brightness and fall still. That is the paradox of creation. The brighter the fire, the deeper the shadow it leaves behind. Every supernova, every galaxy, every life, all of it made possible by the same process that ensures its eventual extinction. Entropy is not the enemy of creation, it is its consequence. The universe does not die because it is flawed. It dies because it once lived. From a scientific view, this is inevitability. Energy disperses, temperature equalizes, order declines. But from a human view, it feels like heartbreak. The sky we adore, the one that has inspired gods, poets, and lovers, is temporary. We exist during a cosmic springtime, when light still fills the dark. We are witnesses to a miracle that will never happen again. In the far future, when the stars have gone, the universe will still contain the memory of its brightness. The infrared echoes of white dwarfs, the faint hum of decaying particles, the last photons from dying galaxies, stretched beyond all color. Even in its silence, the cosmos will remember that it once sang. It is tempting to imagine this as tragedy, but perhaps it is simply completion. The stars were never meant to last forever. Their purpose was to build, to forge matter, to give rise to complexity, to make possible the brief moment when something could look up and understand. We are that moment. Consciousness is the universe witnessing its own light before it fades. The death of stars is not just the end of illumination. It is the transformation of energy into history. Every atom in your body, every thought in your mind, was once part of a star's furnace. When the stars die, they return to silence, but their work remains, imprinted in the matter that once glowed. In that sense, nothing truly ends. The universe doesn't stop. It evolves toward stillness. As the last galaxies dissolve, as the cosmic web unravels, as even the black holes vanish into radiation, something of that story persists. Not in sound, not in sight, but in the memory of existence itself. For every end contains its own echo. The universe, even in darkness, will still be. The final act of creation is not destruction. It is forgetting. Light forgets how to shine, matter forgets how to move, and time forgets how to pass. The great stage of existence will remain, but the play will have ended. The curtain will fall not with a crash, but with an endless, peaceful silence. And perhaps, in that silence, there will be beauty. The universe will rest, complete. All its stories told, all its fires burned. It will be the ultimate stillness, the echo of infinite energy finally at peace. The last star will shine, unseen and unremembered, but its light will still move outward, endlessly, into the expanding void. A final message from the cosmos to itself. And somewhere, buried in the cold eternity that follows, that message will remain. A single photon, still traveling, still carrying the memory that once, long ago, the universe was bright, even in the darkest voids. The echoes of the first light still whisper. It would be easy to believe the universe has gone dark, that the death of stars and galaxies marked the final extinguishing of illumination. But light is cunning. It does not surrender easily. Though the visible cosmos fades, the energy of its ancient brilliance endures, transformed, scattered, hidden, yet never destroyed. Somewhere in the deep fabric of existence, the remnants of light still hum. The story of this hidden light begins at the dawn of time, the instant when the universe itself became transparent. For nearly 400,000 years after the Big Bang, the cosmos was opaque, a churning soup of charged particles where photons were constantly scattered. But as the universe cooled, protons and electrons combined to form the first atoms. Suddenly the fog cleared. Light escaped its confinement for the first time. A brilliant burst that flooded space in every direction. That ancient light is still here. We call it the cosmic microwave background, or CMB. the oldest relic in existence. Once it was fierce and white-hot, a blinding glow with the intensity of a star's core. Now, after 13.8 billion years of expansion and redshift, it has cooled to just 2.7 Kelvin above absolute zero. It fills the universe as a faint microwave radiation, invisible to human eyes but detectable with delicate instruments. It is the fossil light of creation, photons that have traveled across the cosmos since the moment time itself became visible. When we tune into this background, we are not hearing a metaphor. We are literally detecting the afterglow of the universe's birth. Every faint fluctuation in its temperature, just millionths of a degree, encodes information about the first structures to form. The galaxies, clusters, and filaments we see today were once tiny ripples in that light. The CMB is not merely a remnant, it is a map of potential, the memory of light that built everything that came after. But the CMB is only one part of light's hidden legacy. All across the universe, photons continue to exist in forms we can no longer perceive. Some have been stretched beyond visibility, diluted into the infrared and radio bands. Some have been absorbed by dust, re-emitted as warmth. Some have been captured by gravity, bent and refracted into the shapes of unseen things. Gravitational lensing, one of Einstein's most elegant predictions, reveals that light is not immune to the pull of mass. When photons pass near a massive object, like a galaxy cluster or a black hole, their paths curve. Space itself is bent, and light follows the bend. The result is a cosmic mirage, distant galaxies magnified, duplicated, or ringed into arcs of ghostly brilliance. Through lensing, the universe paints with distortion, using gravity as a lens to show us what would otherwise remain hidden. Even now, in regions of the universe long gone from view, gravitational lensing preserves faint echoes of their light. A photon that left a distant galaxy billions of years ago might pass through multiple gravitational wells before reaching us, its path stretched across time and space. Each deflection is a trace of memory, a record of where matter once was. The universe, in this way, becomes its own archive, sculpting light into invisible shapes that endure even after their sources have gone dark. But not all light escapes. Some is captured completely, pulled into the gravitational grip of black holes. To the outside observer, this is annihilation. Photons spiraling inward, red-shifting to infinity as they approach the event horizon, frozen in place from our perspective. Then gone. It seems like the ultimate erasure. Yet even here, light does not truly die. A photon crossing the event horizon does not cease to exist. It continues along its path, trapped forever inside. From our perspective, we can no longer follow it. Not because it vanishes, but because space-time itself folds inward. Inside, it joins the great unseen, a vault of imprisoned energy sealed by the curvature of gravity. Each black hole is a kind of cosmic reliquary, holding the unobservable remnants of all the light that ever fell within it. And paradoxically, black holes shine, not in visible light, but through the faintest radiation imaginable. Hawking radiation, born from the quantum fluctuations at their edges. According to quantum theory, pairs of virtual particles constantly appear and vanish in the vacuum. Near the event horizon, one member of the pair may fall in while the other escapes, carrying away energy. Over unimaginable timescales, This process causes black holes to evaporate, returning their imprisoned energy, photon by photon, to the universe. The vault eventually opens, though the release is faint and slow. Even at the universe's end, when the last black hole decays, that final trickle of radiation will be light, the last whisper of the cosmos before silence. Every photon born within the first moments of creation will have either traveled eternally or been transformed through countless cycles, but none will have truly ceased. In that sense, light is the most faithful companion of existence. Matter may collapse, time may stretch, even space itself may dissolve. But light endures, slipping between states, hiding in new forms. The universe recycles it endlessly. Photons become heat, heat becomes motion, motion becomes structure, and structure gives rise to new sources of light. What we call the death of light is merely its migration into subtler domains. Consider the infrared glow of interstellar dust, the gentle warmth of matter bathed in starlight. Those photons, absorbed by grains of carbon or ice, re-emerge as longer wavelengths, continuing their journey in another register. They illuminate nothing visible, yet they sustain the cosmic balance. The unseen far outweighs the seen. Most of the universe's light lies hidden, scattered in frequencies the human eye can never perceive. The same is true closer to home. Earth's warmth, the glow of a forest at night in infrared, the radiance of your own skin, all are echoes of sunlight transformed. Every photon that touches you becomes heat, motion, life. The light that once burned in stars now burns in cells, powering the heartbeat of organisms billions of years removed from their source. You are, in a literal sense, the continuation of ancient light, slowed, rearranged, living. Perhaps that is the deeper truth. Light does not end because it never belonged to one place. It is motion itself, endlessly transforming form into form. The photons trapped behind horizons, the radiation lingering between galaxies, the microwave hum filling all of space. They are the same thing expressed through different ages of the cosmos. Light is the persistence of energy made visible, the universe's way of remembering that it exists. Even the darkest regions, the so-called cosmic voids, are not truly empty. They hum with faint radiation, the scattered debris of photons stretched and cooled beyond sight. Astronomers have detected diffuse extragalactic backgrounds across every wavelength. Infrared, microwave, radio, even X-ray. Together they form a hidden web of illumination that binds the cosmos long after the stars are gone. The night may appear black, but in reality, it glows faintly with the afterimage of everything that ever was. In the deep future, as the universe grows colder, this hidden light will continue to fade, but it will never vanish completely. Even after the last proton decays, when matter itself disintegrates, the energy released will radiate outward as light. The universe's final act will be luminous. It began in brightness, and it will end in brightness, not visible to eyes, but present as the last signature of being. From a philosophical view, this persistence suggests something profound. If light is never truly lost, then neither is the information it carries. Physics tells us that energy and information cannot be destroyed. They only change form. The photons escaping a dying star, the Hawking radiation from an evaporating black hole, the microwave hum from the dawn of time, all of them contain the story of what once existed. The universe forgets nothing. It merely hides its memories in places we cannot yet see. Perhaps, then, black holes are not tombs, but archives, places where information is encrypted in the curvature of space-time, waiting for release. Perhaps the cosmic microwave background is not a ghost, but a message. The light of creation still speaking across billions of years. Perhaps light, in all its disguises, is not simply illumination, but communication. The universe forever sending itself a signal to remember. Even now, as we study faint photons arriving from the edge of the observable cosmos, we are reading these ancient messages. Each one is a note in the universe's ongoing conversation with itself. When we detect the microwave background, we are hearing the echo of the first light. When we observe gravitational lensing, we are watching light bend to reveal the invisible. When we measure Hawking radiation, we are witnessing the return of what was once thought lost. Light's persistence challenges the finality of death, not just cosmically, but philosophically. If energy cannot be destroyed, then perhaps existence itself cannot truly end. Everything we see, everything we are, is a brief pattern of energy caught in motion. When that pattern changes, the light within it simply continues elsewhere. Scattered, red-shifted, absorbed, reborn. In this sense, immortality is already real, not for individuals, but for light itself. The photons that once illuminated the first stars still wander through the void, older than galaxies, still carrying the memory of their origin. They pass through clusters, slip around black holes, fade into microwave hum. But they persist. Light does not die. It becomes the silence that holds the universe together. And that silence is not emptiness. It is fullness beyond perception. A vast reservoir of energy woven through every atom, every vacuum fluctuation, every point in space. The cosmos, even at its coldest, still glows with potential. The hidden vault is all around us, an invisible cathedral built from the ghosts of photons. We live inside it, warmed by its whispers, sustained by its invisible gift. Even now, when you stand beneath the stars, every patch of darkness between them is alive with ancient light. It may not reach your eyes, but it passes through you. Endless rivers of radiation, traveling since the dawn of time, threading through your body, through the planet, through the atoms that were once stars themselves. You are part of that hidden vault. Your thoughts, your warmth, the light that reflects from your eyes, all are continuations of that same primordial fire. The photons that left the first galaxies are still here, diffused, transformed, encoded into everything that exists. Even in the darkest voids, the first light still whispers, not as color or brightness, but as being itself. The universe may one day fall silent, but that silence will hum with the memory of illumination. Light will have found a way to live on, not as sight, but as truth. And so, the story of light does not end in death. It ends in transformation. A cycle of energy endlessly reshaping itself. A testament to the fact that even in the face of infinite expansion, existence refuses to vanish. The cosmos may grow cold, but it will never truly be dark. For light is not gone. It has only gone deeper, hidden in the folds of space, encoded in gravity, humming in the microwave sea, waiting perhaps for someone somewhere to listen. The universe will not end in fire, but in fading light. There will come a time, countless trillions of years from now, when even black holes, the final anchors of creation, begin to dissolve. The stars will have vanished. The galaxies will have faded. All that remains will be darkness, a cold ocean of invisible energy, thin as breath. Yet even here, the story is not quite over. Something still stirs. The last light, faint and trembling, whispering through the void. The end of the universe is not a single moment. It is a process, a slow unwinding of everything that once was. Entropy, the natural drift from order to chaos, has been increasing since the beginning. Every star that burned, every atom that fused, every collision and collapse was part of that inevitable march toward equilibrium. The second law of thermodynamics is the ultimate destiny of all things. The cosmos began as low-entropy perfection, a concentrated spark of potential, and ever since it has been exhaling its structure into simplicity. At first, the decay is beautiful. Stars die, but their ashes create planets. Galaxies collide, but from their chaos arise new suns. Energy disperses, but life briefly emerges in its wake. Entropy creates complexity on the way to its own dominion, but in the end, there will be nothing left to reshape. All gradients will have flattened. All motion will have slowed. The universe will be full, but full of sameness. The last chapter of cosmic time begins with the death of black holes. Hawking's revelation, discovered through the marriage of general relativity and quantum mechanics, was that black holes are not eternal. They radiate, faintly, invisibly, but persistently. The quantum vacuum, even in perfect emptiness, seethes with fleeting particles that pop into and out of existence. Normally, these pairs annihilate instantly. But near the event horizon, one particle may fall in while the other escapes. The one that escapes carries energy away, reducing the black hole's mass. Over unimaginable spans of time, this slow leak continues until nothing remains. For small black holes, this process happens quickly, in seconds or less. But for the supermassive giants at the centers of galaxies, the timeline is almost inconceivable. A black hole the mass of our Sun would take 1067 years to evaporate. A black hole with 1 billion solar masses would take 2100 years or more. To comprehend such numbers is impossible. They dwarf the age of the universe by factors beyond imagination. Yet, given enough time, even these titans will yield to the patient erosion of quantum law. As black holes evaporate, they glow, not with visible fire, but with Hawking radiation, faint and cold. In their final moments, they flare in a brief burst of light, releasing their trapped energy back into the cosmos. The last glimmers of the universe will not come from stars, but from the death throes of the most perfect darknesses ever made. Imagine it. A universe devoid of matter, its only illumination coming from the slow disintegration of the things that once devoured light. Each black hole shrinks, flickers, and disappears, a candle burning backward, giving back what it once took. When the last of them fades, the cosmos will be filled with radiation so sparse that entire galaxies of space lie between single photons. This is the radiation era, the final act. The universe will be dominated not by matter or stars or gravity, but by light so weak it can no longer warm, reflect, or reveal. These will be the last photons, their wavelengths stretched by the ongoing expansion of space until they are longer than galaxies, colder than thought. Each one carries the last breath of the universe's energy. At this stage, the temperature of the cosmos will hover infinitesimally above absolute zero, perhaps 1030 Kelvin, or even lower. There will be no heat gradients, no movement, no interaction. The photons will drift through a cosmos of near-perfect emptiness, their energy so slight that they barely exist at all. The universe will have become a perfect equilibrium, the heat death foreseen by thermodynamics. Nothing more can happen, because all possibility for change will have been exhausted. This is the ultimate stillness, the long night after eternity's sunset. But the story of light is not just physics. It is memory. Every photon carries a record of what came before. The echo of atoms, the breath of stars, the reflection of life. Even at the end, that memory persists. The last photon is not meaningless. It is the final witness, drifting endlessly through the cold, holding the faint echo of everything that once was bright. And though it travels forever, there is nowhere left to go. The fabric of space itself continues to stretch, pulling the photon thinner, slower, dimmer. Eventually, its wavelength may exceed the size of the observable universe. It will become indistinguishable from the vacuum itself, not destroyed, but absorbed into the silence. In that moment, the universe achieves completion. The poets of physics might call it the still point. All energy distributed, all tension resolved, every difference of temperature, density, and motion erased. What remains is not absence, but perfect symmetry, a state so calm, so uniform, that even time loses meaning. When nothing changes, there is no before or after, only endless, frozen being. To human minds, this sounds like death. But to the universe, it may be peace. The cosmos is not mourning its lost light. It is returning to balance, the same balance from which it once exploded. The end mirrors the beginning. The singularity that birthed time was infinite energy in no space. The heat death that ends time is infinite space with no energy. The two are reflections of one another, the inhale and exhale of existence. Perhaps this symmetry is the universe's most profound secret, that death and birth are not opposites, but mirrors. In the black silence after the last light fades, the quantum field, the invisible ocean from which all particles arise, will still exist. It is never truly empty. Tiny fluctuations, brief sparks of virtual energy, will continue to flicker in and out of being. From these, new universes might someday be born. Cosmologists call it the multiverse hypothesis, the idea that our universe is just one bubble in an eternal foam of creation. Each bubble expands, cools, dies, and gives rise to others, endlessly recycling the energy of existence. If that is true, then the death of light is not the end of everything, but a transition, the passage of energy back into the potential from which all things arise. The last photon, fading into the vacuum, might not vanish at all. It might become the seed of a new reality, the spark that begins another cosmos, somewhere beyond the reach of our perception. There is a quiet poetry in that idea. The light that once illuminated worlds becomes the whisper that creates new ones. The final sigh of one universe becomes the first breath of another. Entropy, at its ultimate extreme, circles back to renewal, not through miracle, but through the deep logic of physics. And yet, for us, the emotional weight remains. We live in the only luminous moment the universe will ever truly know. A brief interlude between two eternities of darkness. Every sunrise, every reflection, every glint of water or flare of nebula is a miracle of timing. We exist in the golden age of visibility, when light still dances freely before it vanishes forever into the long night. To think of the end is to feel the fragility of now. The photons that warm your skin, that illuminate your eyes, that paint your world. They are the survivors of countless transformations, the descendants of the first fire. They will continue long after we are gone, traveling outward, red-shifting, stretching into memory. But even they will one day fade into the cold. When that day comes, the universe will no longer have witnesses. It will no longer see itself. Consciousness, the brief spark of awareness that allowed the cosmos to reflect on its own beauty, will be gone. The universe will be blind again, not because there is no light, but because there is no one left to call it light. And yet, perhaps awareness itself was never separate from the universe's fabric. Perhaps we were not observers of the cosmos, but expressions of it. Moments when the universe became self-aware through light. If so, then the final fading of photons is not a tragedy, but a return. The cosmos will sleep again, having briefly awakened to admire itself. The universe will not end in fire, the physicists say. And they are right. It will end in something gentler, something more complete. The quiet diffusion of all that ever was into perfect equilibrium. Fire consumes. This ending gives back. It returns every atom, every wave, every spark to the stillness from which it came. We might imagine that last moment, though moment no longer has meaning. Somewhere in the vastness, the final black hole flickers. Its mass, once beyond measure, has dwindled to dust. A brief pulse of radiation escapes into the frozen dark. The last photon of the universe, born not of fusion or decay, but of pure quantum uncertainty. It travels outward, though there is nothing left to reach. Its wavelength grows until it becomes infinite. And then there is only silence. But this silence is not despair. It is completion, the final note resolving into harmony. The universe, having spent its energy in creation, now rests. The great play of time concludes, not with applause, but with stillness. Every light, every voice, every motion that ever was is contained in that stillness. Not lost, but folded in. In that way, the universe's final breath is not a death rattle, but a sigh of relief. After eons of expansion, heat, motion, and struggle, existence finally comes to peace with itself. The laws of physics, relentless, beautiful, and fair, have run their course, and perhaps that last photon, endlessly stretched across eternity, still carries meaning. It may be faint beyond measure, its energy nearly zero, yet it exists. It is proof that the universe once burned, that there was once something instead of nothing. It is the faintest echo of being. If there is any poetry left in the cold, it is this. Light was never truly defeated. It simply became too vast, too subtle, too quiet for eyes to follow. It dissolved not into darkness, but into equilibrium. the perfect balance of everything that ever was. The universe began as light, and it ends as light, not bright and roaring, but gentle and eternal, stretched thin across forever. Time itself will shiver one last time as the final photon fades. And then, stillness. The universe will not end in fire, but in fading light. And somewhere in that infinite calm, the memory of illumination will remain, not as a flame, but as a feeling, the echo of warmth in absolute zero, the softest glow in perfect silence, the last light, drifting forever, carrying with it the story of everything that ever dared to shine. What if the last light isn't out there, but in us? For all the grandeur of galaxies and the eternity of stars, there exists a quieter kind of illumination, one that burns not in the vacuum of space, but behind the fragile windows of the mind. Long after the cosmic fires fade, a different fire endures: consciousness. It is faint, delicate, easily extinguished, yet it glows with something the universe itself rarely achieves: awareness. If the cosmos began in brightness and ends in darkness, perhaps the light within us is its last attempt to see itself before the curtain falls. Every act of perception is a resurrection of light. The photons that once left a star and journeyed across unthinkable distances finally end their long voyage in the human eye. There, they strike the retina and trigger a chain of electrochemical reactions, transforming radiation into sensation. The spark becomes sight. But vision is not the end of light's journey. It is the beginning of another. Within the neural labyrinth of the brain, patterns of energy arise, not of photons now, but of meaning. The mind translates physical light into the illumination of understanding. The outer universe becomes inner. Awareness. Neuroscience calls this electrochemical orchestration, the neural correlates of consciousness, the intricate symphony of neurons firing in precise sequences that give rise to thought, emotion, and awareness. Yet, even the most advanced science cannot say how this happens. How does the cold firing of neurons become the warmth of experience? How does light, absorbed and processed, become the sense of "I see"? Perhaps the answer lies in light itself. In the 20th century, researchers discovered that the human body emits faint photons, particles of visible light, through biochemical reactions in cells. These biophotons, though unimaginably weak, form a kind of internal radiance. They are produced in the mitochondria, the powerhouses of our cells, as byproducts of metabolic reactions. Sensitive instruments have measured these emissions from the brain, suggesting that neurons might communicate not just through electricity and chemistry, but through light. If that is true, then consciousness may literally glow. The brain, in this view, becomes a living cosmos, a miniature galaxy of firing neurons connected by shimmering threads of light. Each thought, each dream, each memory could be a flare in this internal firmament. Some scientists speculate that biophotons could even form a quantum communication network inside the brain, allowing information to be transmitted through coherence, much like lasers, or perhaps like stars in resonance. It is a poetic idea that within the human mind, light continues its story, reborn as awareness. The same photon that once left the sun to illuminate the earth may, through a cascade of transformations, end its existence as the flicker of thought in a human being. The universe, having once filled itself with starlight, now fills itself with self-reflection. The parallels between consciousness and light are ancient. Mystics and philosophers across ages spoke of enlightenment, awakening as a form of illumination. Plato's cave, the Buddhist flame, the divine spark, all metaphors of seeing as understanding, of light as knowing. Even the language of discovery borrows from brightness, insight, clarity, revelation. To be aware is to be lit from within. But modern science has begun to circle this ancient intuition from another direction. Some physicists and neuroscientists suggest that consciousness might be a quantum phenomenon, a process emerging from the subtle interplay of particles and fields that underpin reality itself. The OR theory, proposed by Roger Penrose and Stuart Hameroff, posits that microtubules within neurons might maintain quantum coherence, giving rise to consciousness through orchestrated collapses of wave functions. In this model, awareness is not merely computation. It is quantum decision, the universe choosing a reality through the lens of experience. Whether this theory is correct remains debated, but its implications are profound. It suggests that consciousness is woven into the very fabric of the cosmos, that our awareness is not an anomaly, but a continuation of the same laws that govern light. Just as photons exist both as waves and particles, perhaps consciousness exists both as matter and mind, a duality between the measurable and the felt. And if that is true, then consciousness might be the universe's most refined form of illumination. When you think, when you feel, when you remember, you are performing the same miracle that stars once did, converting energy into meaning. You are the cosmos burning inwards. In that sense, light has never truly left. It has simply gone home. Consider the possibility that the final chapter of the universe is not written in physics, but in perception. When the last star fades, when the last photon stretches into invisibility, what remains? Awareness, the last observer, the final mirror. Perhaps the reason the universe produced consciousness was to ensure that its beauty would not go unseen. That, before the long silence, it could glimpse itself and whisper, "I was here." Every human eye that ever looked upward, every mind that ever wondered about its place among the stars, has been part of that cosmic act of remembrance. We are not separate from the universe. We are its eyes, its neurons, its reflection. When we gaze at the night sky, we are the cosmos contemplating its own light. We are the bridge between the visible and the invisible, between what shines and what knows. But this light of consciousness is fragile. Like a candle in the wind, it depends on the precise conditions that sustain life: oxygen, warmth, chemical balance, time. One small fluctuation, one cosmic accident, and the flame could go out forever. Yet that fragility is what makes it sacred. In the immensity of space, against the weight of entropy, awareness stands as the last defiance of darkness. If one day, eons from now, all external light has vanished, and all stars are cold, perhaps the memory of light will persist not in matter, but in awareness itself, the echo of perception. For what is light, if not the experience of illumination? Without consciousness, light is meaningless. It exists, but it is unseen. It moves, but it is unsung. In that sense, it is not light that makes the universe bright. It is the act of seeing it. Even now, the glow of thought mirrors the glow of stars. Brain scans show bursts of energy when we imagine light, when we picture the sun or dream of galaxies. The neurons that activate during vision are the same that fire during memory and imagination. We do not only receive light, we create it. We generate brightness within ourselves, replaying photons that no longer exist. In our minds, light is reborn endlessly, and if consciousness fades someday, perhaps it will not end abruptly. Perhaps awareness, like light, will dissolve gently, thoughts stretching into silence, memories elongating into stillness, until what remains is peace. Just as the last photon merges with the fabric of space, the last spark of consciousness may merge with the fabric of being. The final flame does not go out. It becomes everything. That is the paradox of illumination. It burns by consuming itself. To shine is to spend energy, to give away existence. The stars gave their light to form us. We spend our awareness to understand them. In that exchange, something immortal happens, not in form, but in meaning. The universe, through us, becomes aware of its own impermanence. The end of light, then, is not the end of knowing. It is knowing that becomes light. Perhaps that is what ancient mystics intuited when they spoke of the eternal spark within, that the final truth of the cosmos is not found in equations, but in experience, that the ultimate light is not the one that travels through space, but the one that travels through thought. We do not simply witness the universe's fading glow. We are that glow, condensed into awareness. Imagine, for a moment, the stars fading one by one, galaxies dimming, black holes evaporating, space growing silent. And yet somewhere a conscious being dreams of that darkness. In that dream, the stars still shine. In that imagination, the light still lives. That is what it means to be human. To carry within us the echo of illumination, to recreate the cosmos in our minds. The light that built the world is now the light that builds meaning. When the universe finally rests, when every photon has stretched beyond reach, when entropy has won, perhaps consciousness will remain as the faintest shimmer in the void. Not a flame, but a reflection. The universe will have remembered itself through us. We are that memory. We are the last witnesses to the miracle of being, the final lanterns in a cosmos that once blazed with glory. Each heartbeat, each thought, each dream is a pulse of the universe's original fire, still burning in miniature. And when that final light fades, when thought itself dissolves back into silence, it will not be defeat. It will be completion. The light within will not vanish. It will return to the source from which all light came. The stars are dying. The galaxies are drifting away. The universe is growing cold. But in us, for this brief, immeasurable moment, it burns. What if the last light isn't out there, but in us? Then even when the cosmos falls asleep, it will still be dreaming. Through every mind that ever wondered, every soul that ever saw, every consciousness that ever carried the memory of light. And in that dream, the universe will remain illuminated forever. Perhaps light was never meant to last, only to remind us we once saw. The story of the universe began in brightness and ends in quiet. The stars were its first words, the galaxies its great sentences, and consciousness, the final whisper before the page turns blank. But even as the ink of existence fades, something remains between the lines. The memory of illumination. We have followed light from its birth in fire to its death in silence. We have seen it stretch across space, bend under gravity, dissolve into heat, and reappear as thought. It has taken the form of stars, of eyes, of minds. It built the cosmos and then looked back upon itself through the lens of awareness. In every chapter, light has been both the storyteller and the story, the thread connecting the physical to the spiritual, the seen to the known. And now, as the cosmic dawn fades into endless night, a final paradox reveals itself. The end of light is not the end of seeing. Because to see was never about photons alone, it was about the act of wonder. The universe does not need to glow for meaning to exist. It only needs to have been seen once by something capable of awe. When the last photon drifts into nothingness, it will not vanish. It will merge. The light will become the silence, and the silence will carry its echo. Every sunrise that ever was, every dream of brightness, will still ripple through the fabric of eternity as memory, the ghost of illumination woven into the structure of being. Even in perfect equilibrium, the universe will remember that it once burned. And perhaps that is enough. For what was light, truly, if not curiosity itself? The urge of the cosmos to know its own shape. The stars were never separate from us. They were the universe's first eyes, scattered across the dark. We too are extensions of that same impulse, light condensed into awareness, reflecting back at itself through thought. The cosmos looked outward through stars, and inward through us. That cycle is the dawn that never ends. Even when the galaxies dissolve and the temperature of space approaches absolute zero, the act of wondering will remain immortal in concept. A spark that does not require fuel, only remembrance. Every question ever asked, about time, about origin, about purpose, is a photon of meaning, still moving, still illuminating the unknown. The universe may sleep, but the idea of seeking light will forever shimmer at its core. Darkness, then, is not the opposite of light. It is its continuation. The night sky we gaze upon is already mostly empty. Yet we find beauty in that emptiness, meaning in its silence. Perhaps the future cosmos, stripped of all brightness, will not be tragic, but serene, the great exhale after a symphony, the moment when every note has settled into stillness. Somewhere, in that infinite calm, lies the echo of us, not in matter or memory, but in significance. For meaning itself does not die when light fades. It endures as possibility, as the lingering awareness that something once existed, and that existence mattered. Perhaps that is the true nature of eternity. Not endless time, but endless reflection. The cosmos, having created eyes to see, minds to wonder, hearts to feel, has already completed its purpose. It has become self-aware. It has known itself, if only for a fleeting instant. Everything that follows, the fading, the silence, the cold, is simply the echo of that knowing reverberating through forever. The universe does not need light to shine. It shines through the memory of illumination. Every time a being looked up and felt wonder, the cosmos renewed its own existence. Every time curiosity was born, another dawn began. The act of looking is creation. To seek light is to keep it alive. And so, Even when the galaxies fade beyond vision, even when all photons have stretched into invisibility, the flame remains, not in space, but in the idea of space. Not in stars, but in the dream of stars. The universe dreamed of light, and through that dream, it became real. Now, as it drifts back into silence, that dream continues, quiet, unending, unseen. The cosmos may rest, but it does not vanish. It carries within it the memory of everything that ever shone, every consciousness that ever wondered, every flicker of awareness that dared to ask why. That memory is the dawn that never ends. Perhaps that is how the story truly closes, not with extinction, but with remembrance. Light does not die. It transforms into meaning. Darkness is not emptiness. It is potential waiting to be seen again. The end of light is not a tragedy. It is a promise that wherever curiosity exists, a new dawn will rise. And so we look up, still, into a sky already ancient, already dimming, yet still alive with the ghosts of stars. We look not to measure distance or time, but to remind ourselves that we once saw, and that seeing, that fragile, magnificent act of awareness, is enough to light eternity. Because perhaps the universe's final truth is this: it was never about how long the light lasted. It was about the fact that it was. That once there was brightness. Once there was wonder. Once there was us, the universe, knowing itself. And that is the dawn that never ends.